Hola, mucho gusto. And the stream is started. Let me check the stream. Give me a minute. Oh, switch account. Let me look. Wait, what? Okay. Yeah. So, till now, where were we? We were on dynamic programming. In last stream, we did this 1DDP, and then we started with 2DDP, and we solved, I guess, one problem. Now we'll be starting from here, and I'll try to complete at least all of these problems today on this stream. Don't know for how long it will go, but this goes on till I get bored or till I get hungry, and then I'll play Valorant. Let's go. So I'll start with unique paths, C++. Solve this problem first in 2024 July. So that I solved it in C++ at that time. So let's see if we can solve it now. So my aim is, whatever I solved till now was trying to get down the answer in form of recursion, then memoizing it, and then turning it into bottom-up DP. But the approach that I'm taking right now is identifying whether it is a DP problem right from the start, and then trying to use my intuition just to form the DP solution right away. So if after this playlist of 2DDP, if I'm able to get that, it's good. And let me begin. I have paper and pen with me today as well. What is this? 8 moves. Whatever. Yeah. So there is a robot. A robot is at the start position and it goes to the finish position. There are no obstacles or nothing here. So what I have to return, given the 2 position MNN, return the number of possible unique paths that the robot can take to reach bottom right corner. Is the volume okay? Because today I'm not wearing my headphones. Check it. Yeah, volume is good. Let me share this link quickly to my friends, mi amigos. Join Crow Live. Okay. Yeah, so from start till the end, I have to find the number of ways in which the robot can go. What is the catch here? The catch is that the robot can move either down or right, so it doesn't move left at any given point. So this robot can move right, and then down, right, down, or down, right. So the down makes it change its column, its row, whereas moving it on to the right makes it change its column. Okay, so the robot at any point can be in the different row when it takes a downward move, right? It will surely be in a different row when it takes a downward move. Whenever it takes the left move, it will be in the same row but a different column. This is one thing. So this is one good thing that we have figured out. Now think in while filling up the DP table. So whatever the DP table or DP array or DP3, DP whatever it is, whatever it will be, the main thing that we need is the filled out values, which are derived from the base case of recursion. So if I want to skip recursion in this case, then I have to think deeply. So what will my DP array contain? What am I trying to save here? What am I trying to save? What am I trying to memorize? That memorization goes into the DP array, into my DP. So think. So what are we supposed to find? Number of ways. Yeah. So one thing is, so if I'm at this point, then if I want to move from this point to the next point, then the number of ways I can get to this point plus the number of ways I can get to this point, right? No, wait a minute. So the number of places that I can get to this point from the start plus the number of places I can get to this point from here will give me the total number of places that will take to come to this point. So there needs to be something filled up. So obviously I know that to get this position from here, there is one way. So let's say if I try to remember, if I try to memorize all the states in this, so that is my DP array will be of size m cross n, right? And first I'll make it 0 0 into n for underscore in range n. Okay, this is the same matrix as the question, and dp of 0 comma 0 is equal to 1. There is one way to come from 0th place to stay at 0th place. Now in order to come to first place, how do I fill this up? How do I fill this up, man? Yeah, so what are the moves that I have? Either to move n plus 1 or to move n plus 1. Okay, so let me run a for loop for I in range n, for j in range n. What's up with this indentation, man? Did I mess up? Yeah. Yeah. So now I'm looking out for everything, all the possible columns here. How do I fill this up? Okay, so if there is just up and down, there is no right. So dp of, so to get to all these squares there is just one way, right? So I think, because anyways we can't come up, so to come to all these paths 1, 2, 3, 4, 5, 6. There is one way. Also, to come to all these paths, there is one way. If I is equal to 0, if I is equal to 0 or j is equal to 0, then is it right about j is equal to 0? Yes, surely it is, because it's just right and down. Then dp of I j is surely equal to 1. It's just one way. So through this I filled up this table and this part. Now if it is anything other than that, what happens? So if it is anything other than that, the number of ways that took me to come to this point will be the number of places that it took to come to this point and this point. You write about it. Okay, now I think we are building the logic here. And if so we are doing -1, okay, so I -1, so surely won't be on 0, right? If I is greater than 0, if I is greater than 0 and j is greater than 0, then and only then my dp of I comma j will be equal to number of ways that I can get to I minus 1 j plus dp of I j minus 1, right? Number of ways that I can get to this is the number of ways I can get to here plus number of ways I can get here. So this is right and down. Okay, so yeah, we keep on filling this, and then I'll return dp of, okay, so let's do a dry run. This runs here, this goes here, this is 0, this becomes 1. So for this gets built, for this gets built, for this gets built, this gets built, for this comes here, it is 0, it gets filled, and comes here. So dp of I minus 1 j minus 1, not I minus 1, m minus 1, n minus 1 should return me the answer. Let's see what happened here. Good. Is it working on our test cases? Okay, so is this memory? Yeah, so we took in more memory. Now we need to optimize our memory. Could you train an AI model and predict movements just by looking at them? गाने लगा कर गाने कॉपीराइट, नॉन कॉपीराइट वाले गाने लगाने पड़ेंगे. नॉन कॉपीराइट वाले गाने लगाऊं? Okay, subscriber Swagist is saying that put some songs in the background. Let me try to search some. My throat is gone. Let me mute myself first. Yeah, I'm playing some royalty free music. Wait, और तू भी कोई देख रहा क्या? Okay, let's put some songs. loud is my sound? Let me test. Hello, hello. Okay, back to my solution. So what can I improve here? So my DP in this, the solution that we observed here was my DP depending only on my previous squares in my current list and this previous array, that is the above column. So instead of taking the DP of size this, I can just reduce my DP to just of the size of this first element. It is O into N, right? Yeah. So I've reduced my DP to this, and for starting, that is this position, it is always 1. That is, this is what I know, right? So previous of 0, so this is DP, and then for I in range M and for J in range N. So let's remove this I in range N. Okay, for J in range N, so J just moves from here. Okay, if J is equal to 0, then DP of J will be 1, right? Yeah, right. And if I is greater than 0, if instead of this I'll just do else. What is if, bro? Else. That's what happens is DP of J. Okay, this is not DP of J, bro. So for every loop you must take a new DP. I think this is current. Let's take a new DP. Current of J is I, current of 0 is I, and current of DP, current of J, wait, this, okay. So for calculating this, I'm using this and this. For calculating this, I'm using this. So what if I just use the same block, and the first one is always 0. No, first one is always 1. So in order to calculate this, I'll use whatever it was in previous, whatever it was here plus this, and this comes here. Whatever is here will be this plus this. Okay, I don't even need another cut. So I'll be traversing for J in range N minus 1, and I'll go back to. Okay, but wait. How to calculate this? I need to calculate this. But this will depend on this. So everything depends on this. So this will change this. This will change this. Okay, I can't go reverse. Nice try though. So if I can't go reverse, then I surely need another current DP array. Current of J is equal to 1, else current of J is equal to whatever was my DP. DP of I minus 1 is basically just the DP now. DP of J plus And what is this? Current of j minus 1. dp of I is current, right? Current of j minus 1. Is this correct? This is whatever is up and this is whatever is in left, and then I'll return the current of n minus 1, right? So where have I defined current? Current is equal to same as this. Current is equal to this, and after this loop is done, oh wait, I'm doing it just for once, right? I need to do it for I in range n. Range n. Time complexity won't decrease. I'm just decreasing the space complexity. Time complexity anyways m cross n. And in this place I'll so what happens here is after every iteration is over, when we are calculating it for the next time, whatever current dp it becomes previous. So dp, that this is previous, will be current, right? And then this goes on and we work on dp. Dp will be current, and current is anyways being overwritten, right? So we don't care about current. Let's try to run this. Let's see. Okay, this runs. Did we improve any time complexity? Oh yes, we went from 4 ms to 1 ms for memory. So this was good question. This is done. Now grade unique paths to dp9. Let's go. Next question. Going back to chat. Is there anyone new? 0 viewers. Very nice. Unique paths 2. I have the Python solution as well. Bro. I'm just gonna delete it. Or shall I not delete it? Control Z. I'll just keep it somewhere. Control X. I'll go and paste it in Python. Okay. Back to here, and I'll solve fresh new start. Reading the question. What music is going on? If you are m cross an integer array grid, there is a robot initially located at top left corner. Robot tries to move to the bottom corner. The robot can only move down or right at any point of time. Obstacle and space are marked as 1 and 0. Path is greater than square. There is an obstacle with any possible unique path that you can reach. Okay. This time the only change is there are obstacles in the and the grid is given. Here the obstacle grid is given. So what happens? So while designing a DP solution this time, I think there is an obstacle in the middle. Do we have to return the ways? No, just the outputs. So in this I'll build a similar DP array which will include previous, and this time while doing a check, so dp of ij, dp of, so what am I doing? Current of I. So every time that I calculate current of I, if current of I and J, okay, current of I, if obstacle grade of M and N, obstacle grade of bracket M is equal to 1, then I'll straight away write 0 to it. There are no ways of getting there, and when based on that I calculate, then okay. I don't think this is any different from previous question. I'll go back to previous question and copy paste this approach and try to modify it so that we don't waste time in doing the same things that we already did. Now also one thing, this can be anywhere. So every time what I did was, every time J is equal to 0 I am doing current J is equal to 1, and either move down or right. Okay, this is same. So if J is equal to 0 and if J is equal to 0 and if obstacle path of, where is that obstacle path, obstacle grid of I comma J is equal to 0, then and only then my current of J will be 1, else current of J will be 0. So this is one change that I'm doing, that is not setting the first path as 1 always. Oh, but wait. So now let's say there was a stone here. So in order to get to all these paths below it, it will always be 0 regardless of if it is 0 or 1. So how do I deal with that? In this I've straight away written that for J in ranges, if J is 0. So in this part I need to ignore this condition. I need to remove this condition. This is too this will mess with my logic. Okay, so I need to consider for everyone, that is current of J will be dp of J plus current of J minus 1, but this J minus 1 won't work if my J is 0. So what happens at that time? dp of J plus dp of J. So instead of dp, let me change this name to previous because it's confusing me. This is the previous, okay, and then I'm doing previous is equal to current. Instead of dp I'm just putting previous. Right, so for every current index I'm checking what was above it and what was this. Now I'm just gonna calculate these two things differently. Above is equal to, and on left is equal to. So above was this. This is the solution for the previous answer itself. And I'm just doing above plus left. Okay. Bruh. left. Yeah, now let's modify this in 2 minutes. Okay, for changing this above, so every time I find a stone in this, let's not make another approach. I was thinking of using another variable to tell if I found a stone in the j is equal to 0 first column. If I find a stone, then I'll change that variable, and then if that variable is true, then only my bar will be there, otherwise there will be no bar, is what I thought to do. But we can do it in a better manner, right? Bar is equal to previous of j. First of all, if there is a stone right on the obstacle grid, if obstacle grid of I comma j is equal to 1, then straight away my current of j is equal to 0, and this is in the else part. So if it is not an obstacle path, then it will anyways take the previous of j. Otherwise you will previous of j, no problem here. But on the left there is a problem. What if there is no left? What if there is no left, bro? What if there is no left? For calculating this, current of j will straightforwardly, and we only add if I is greater than 0. That's I or j, bro. That's j, I guess. If j is equal to 0, j is greater than 0, only then I will add current of j plus equals to whatever is on the left. What is on the left? Current of j minus 1. Yeah, let's run this. And is not defined. Okay. M comma n is equal to length of obstacle published grid comma length of obstacle grid of 0th element. Okay, the output is 0 0 0 0 0 0 0 0, bro. What did I consider for this? I considered TS of 0 is 1. That is, have they ever mentioned that there won't be obstacle on the first path? Let's reiterate whatever we have written here, okay? So M&N is correct. I'm making a previous array in order to represent this, and then previous of 0 is 1. But okay, previous of 0 is 1, and this is future. For I'm doing gem, I'm doing previous is equal to current. Previous is equal to current. Oh wait, what? Previous is equal to current. So that means that this line is gone. Okay, so everything is 0 0 from the first. So current of 0 is equal to 1. Yeah, so this previous becomes correct here. Oh, how did it run in previous case then? Let's go. And we're done with second question as well. Now let's go to the solution that I wrote almost an year ago. If obstacle grade of 0, 0 is 1, then return 0. Okay, this is one case that I missed in my current solution. I'm taking previous for iron range n and iron range m. I'm taking temp as a new variable for j in range I. If I 0 to 0 j is equal to 0, only then and then I'm taking temp of 0 is 1. Yeah, right. If obstacle grade of 1 is 0, then temp of j is equal to 0. Else left and up, if j is greater than 0, oh yes, always will be up, left is up, previous equal to temp, previous minus 1, okay, yeah, almost the same thinking. So unique grid path is done. We were able to directly find the solution in DP here. 2 questions are done. Let me check the chat. Hooligan here, but Hooligan is gone. Hooligan says wow. Let me drink water and move on to the third question. What music is going on? Noise. The next question is minimum path sum in grids. This is all on 2D and 3D DPs. There's just one 3D DP or what? Where were we? Minimum path sum, okay. Next question. This also might be solved. Oh, this I haven't solved. Solved it in C++? No. In Python? No. Python 3? Okay, first of all, I'll take this solution. I'll put it somewhere else. क्या कम रहा भाई? Dynamic programming सीख रहा हूँ बमाई. From this. Solving problems on dynamic programming. I'll paste this solution here so that we come back to this once we have found the answer. Not try to look anything, but let's go back. Okay. Now here we are on a fresh start. Minimum path sum. So we are given a grid, m cross n grid filled with non-negative numbers. This is a good point. Non-negative numbers. Find a path from top left to bottom right, which minimizes the sum of the numbers along the path. Okay. So, what does the problem say? The problem says that what will be the brute force approach that I can take? I can find the sum along all the paths that I take, and then I can give the minimum. Another thing that I can do here is, in order to come to a particular point, what is the minimum sum that we can get to till that point, and so on. And that is the main motive of my DP, filling the DP table. I fill the DP table in that way, and I'll return the answer of the last cell block. So this is the approach that I feel is perfect here. Now here also they have given that either we can move down or right at any point. So when it says that I can move down and right in any point, so I can tell that this involves just taking not the 2D DP, just taking a 1D DP of previous. Okay, so what is the minimum sum that I can get in order to reach to this point is 1. In order to reach to this point is obviously 1 plus 3 4. Till this point obviously 4 plus 1 5. It can't be lesser than that. that is how I fill the first table, right? Then what about this? It will be the same for this too. For this here, so what, when I'm filling my DP table, I know the sum of this, I know the sum of this, so I can, and this is m cross n grid, okay? So I can take any of them. So I'll take this first three, and based on that, what will I do now? In order to reach to this point, I can take this. Oh, that is obvious. Now we can either move down or right at any point, right? So when I'm at this point, I'll take minimum of this and minimum of this. Whatever is the minimum, that I will add and update the DP value. So I've got the gist of the problem here. Let me start writing. So I'll take a previous DP array, okay, and I'll take a current DP array, and no, I have to fill it in for I in range, for j in range. What is this? Wait, first of all find the length m cross n is equal to length of grid and comma length of grid of 0. Yeah, this is done. So length of grid of 0 is in what I'll be iterating first. So anyways I have to fill it in. Yeah, so current DP, okay, I'll say DP is equal to, everything will be 0 first, 0 into 0 multiplied by n, right? And DP of 0 is equal to whatever my first element is. What is my first element? Grid of 0 comma 0, grid of 0 comma 0. What the fuck? Mario का music है. For j in range 1 to n, now I have to fill. So the j in range 1 to n will be dp of j plus equal to dp of j is equal to grid of j, grid of 0 comma j plus dp of j minus 1. Yeah, so in this way I filled the dp table for my first line. So now that my first line is filled, in order to fill the next line, what will it be? So let's fill all the lines, run a for loop for I in range m, I का आ गया भाई, for I in range m, for j in range n. So whenever, if j is equal to 0, then what will be minimum? If j is equal to 0, then I have to update my dp table, right? Then my current is equal to current of j will obviously equal to what? Grid of I comma j plus whatever we find in previous. What is previous? Previous is dp of j, right? So j is equal to 0, this j of I will be, this will be the current index here plus this, so this will be 2. What is this? It is the minimum. Are you sure this is the minimum? Yes, this is the minimum sum that I can get to till this point. Else, now here I have to fill the current of j can only be minimum of, current of j will be, first of all it will add whatever is in my current grid, left, right? What is up? What is up? What is up? Up is dp of j. What is left? Left is current of j minus 1. Is it right? Yeah. So in this way we'll fill the table. Now resetting the values. After I'm done my first time writing current, so my dp will now become current. That is previously become current. Let it move on. dp becomes current, okay, and then we come here and then we again set values for dp of if when it is 0 I'm setting current of 0, I'm changing current of 0, and then I'm moving forward and then choosing whatever was behind it. So current behind is already changed. dp of j is already what was in previous, right? Tana. What will I return? dp of n minus 1. Let me try to run this. Yeah, current is not defined. Yeah, so what will be current at any given point? Why am I even using current here? Huh? Can I use dp directly? Okay, if I use dp directly here, then what am I changing here? Whatever is in grid of I plus I plus minimum of dp of j, whatever is in that place itself, whatever is in that place itself. I think I can use dp here, right? Okay, try this. Where is current? So current I'm using dp here. Okay, we get a wrong answer here. So I think we do need to use current. dp is equal to current, and what will be my current? So my current is equal to a similar grid. Oh no, where is it? Nah, bro. There is something wrong here. So I written whatever I was thinking. There is something wrong with current and dp. So dp, let's change this dp to previous so that I don't get confused in what I'm actually doing here. Okay. Then what the hell? Previous of n minus 1. Okay. So my previous is of length n and everything is 0. But then I updated my previous of 0 to be grid of 1. That is correct. And then for j in range 1 to n, I'm just taking previous and whatever is in grid of that plus what was previous. That will give me the path sum till that point. Till here everything is correct, so my previous is all set. Then I take a current, I don't know why. We'll find out. Then I'm running for I in range m. So I is equal to 0 0. So I don't have to run. What is my I? Yeah. Okay, so one more case. Why am I starting I from? I have to start I from after 1, right? Because 1 is already calculated. So before this, and trying to, for my case, if m is equal to 1, then I'll return of n minus 1. Yeah, so these are edge case if m is 1. Otherwise we will run our loop from 1 onwards, and then we'll try to calculate this. This is correct for j in range m. So okay, got accepted. So this is my solution. I had to use 2 previous and current here. But what if the thing that I was trying to do is I was trying to eliminate this use of current. So I'm just gonna try using this previous. Instead of current, I'll do previous itself. Try to run this line. I'm gonna run this. Let's see if it works. Oh, it works. So what does this mean? I don't need another DP. Just one DP and changes in that, and it works. But will it submit? Did I try to submit it? Yeah, it runs. Memory bits 94%. What did I do previously? Previously I had previous is none into n for I in range. Oh, I compute. Currently none into n for j in range n. If I 0 and j 0, then only this, else left up float of infinity, and then I'm taking minimum. Previously got current. I don't think we need this current which I've taken here. So I'm improving my space. Instead of 2 and 2 and n. This approach. Yes. So 3 questions are done. Let's take a break here. Am I still on royalty free music? Holy sh! 1 second. No copyright music, good. Yeah. Why are we able to solve the problem so fast? Is it because we know that it is a DP programming, dynamic programming solution, so I'm trying to think it that way. Is it the reason? It can be. Next question, we are done with 2 questions. Now let's solve minimum path sum in a triangular grid. This is another question we have. Where is the solution? We have the solution here. Let's pick this up, cut this down, go to Python, paste this shit here, and just come back to my Python 3. Minimum total. What do you have in minimum total? So the name of problem is triangle. Just triangle, nothing else. Given a triangle array, return the minimum path sum from top to bottom. For each step, you may move to adjacent number of rows. You may move to an adjacent number of rows below. More formally, if you are on index I on the current row, you may move to either index I or index I plus 1 on the next row. Bro, what do you mean? Okay, so So if I am on first index of a row, then if I'll stay in the same column, otherwise I'll move in a different column on the right. So here the state depends on above and diagonally above left. Diagonally above left. Yeah, so this is what we figure out. Also, do we need to take care of any bounds here? So whenever my index will be 0, there won't be above left, and whenever my index is 0, there won't be above left. Whenever it is greater than 1, 0, whenever it is greater than 0, it will be minimum from above and left. Also, the traversal here will be, how will the traversal be? My I, so my j goes, if my I is 0, if my I is 0, my j goes to 1. If my I is 1, j goes to 2. If my I is 2, j goes to 3. What does this mean? It goes till j plus 2. It goes till j plus 2. Am I right? So first of all, here what do I need? What do I need here? If I have so I think for this also a 1D DP is enough. I'll take a previous DP of length n. What is n? No, what is n? So whatever so it goes on increasing, right? 1, 2, 3, 4. If there are 4 elements in my triangle, then the length of my DP should be 4. Yeah. So n is equal to length of what? DP, length of triangle, right? And this is my previous DP that I want to remember. It's correct now. First of all, no, I don't need a separate iteration for the first row, right? I'll start traversing for I in range something, which I'll find out. What is my range of I in range? M is equal to okay. For I in range n and for j in range. So when my n is 0, there is just one element. When there is just one element, the length of that list of one element will always be 1. What does that mean? So when I is 0, j is in range just 0. So I can write I plus 1, right? So j will go till range 0. So j is 0. Yeah, this is right. So this is how I traverse in my triangle. And in my triangle, the only things I care about will be whatever is right up and whatever is diagonally, up, right? Diag up left. Okay. So whatever is up, what will be up? There will always be up, right? So yeah, one more thing before I do this. If I is equal to 0, if I'm on the first column, and the sum will, no, if I'm on the first column and also the first column, that means if I'm on the starting point, in order to reach to this point, my sum will always be triangle of angle of I comma j, right? So what is this? What are we trying to calculate? Previous of I comma j. Why am I writing I comma j? Let's just write previous of 0 comma 0 will be triangle of I comma j, right? So first value is done. And then in the later cases, I'll try to calculate up. And when will I have up? If I will have up if and only if my row is greater than 1. Is float of infinity. Float of infinity, right? If I is greater than 1, greater than 0, then only then my up will be minimum of whatever is at my current previous I and j. Whoa, no bro, just j, right? What have you written here? Yeah. My up will be minimum of previous and j, and whatever is what will be the up will be previous of j. That's right. Wait a minute, why do I even need minimum, bro? Up will be previous of j, and what will be diagonally up? Left. And when will this be possible? This will be possible if my j is greater than 0, then I may have diagonally left, but also also needs to be greater than 0, right? Otherwise I won't have diagonally up left. Even here I'll write the same. We'll see. It will be diagonally left is equal to float of infinity, and then diagonally up left will be what? So my previous DP's answer and my whatever is actually on my previous DP's position, minimum of previous of j. Bro, why am I jumping into previous of j minus 1 is my diagonally up left, because it's previous of j answer, right? And then when you are about to find the answer for your previous of j, this will be whatever is in that position, that is triangle of I comma j, and in this I'll add whatever is minimum from up comma diag up left, right? This is how we keep on updating it, and then in the end I'll return previous of n minus 1. Diag up left is not defined. Bro. Float object is not scriptable. What do you mean, man? Float object is not scriptable. Okay. Otherwise there's no up. It will be 0. Oh wait. Is there end of infinity? take a very large value, man. So it's 10 raised to 4 now. So I'll just take 10 raised to 4 plus 1. 10 power 4 plus 1. Nice. End of reading not scriptable. What the fuck? What's wrong here, bro? If I'm putting up here and then I'm going in a loop, if I is greater than 0, then I'm doing up is equal to previous of G. What happened? What happened to my son? Son, just try to look from the start. Length of triangle is 1, 2, 3, 4. So that will be the length of my DPR that I want. Yes. Then for I in range n. Yes. And for J in range till I plus 1. So when it is 0, 1, 2, 3, it will run for 3 units. 0, 1, 2, 3. Right? Absolutely. If I is equal to 0 and J is equal to 0, then previous of 0 is equal is triangle of the first element in the triangle, that is 2. So my DP now has 2 as its first element. And then okay, all of this should be under else part, right? Yeah, right. And then my up, I'm putting something as up. Local variable is not associated with the value. Bro, what? Oh, we left my son out. Back to that same question. Okay. Now I'm putting up as a very large value. See? And then I'm saying that if I is greater than 0, that means if I move to my next column, next row, only then I'll have an up. Right? What if I don't specify this? What if I say that I is equal to 0? Anyways won't come in this, right? So I don't think I have to worry about up anymore. No. Diagonal left. If I is greater than 0, obviously I will be greater than 0. And if J is greater than 0, so that's one thing that I can have J is equal to 0. When J will be 0, then I have to take when J is greater than 0. So if J is equal to 0, then obviously whatever is in previous step. Alright, bro. So if, let me write one condition here. If J is equal to 0, then previous of J minus 1 is equal to 0, then previous is equal to triangle plus else I have to do something in order to find minimum, right? Else it will be PS of j minus 1. Bro, what is previous? Dumbass. What is previous of j? Previous of j, right? So here previous of j will only be something plus up for this diagonal left. Otherwise it will be minimum of previous minus 1. Yeah, I think this should do the work. Oh, it didn't do the work. What happened to my son? So triangle was this. What is 3 in this case? How the duck? So obviously I'm considering triangle this. So if j is 0, then any ways to come down will be whatever is up, and what was up was previous of j. To make this even smaller, this, then previous of j will increase like this, angle ij. Okay, otherwise previous of j will be angle and minimum of up. What is up? Previous of j will be previous of j itself and previous of j minus 1. Whatever is minimum part sum. Oh, what went wrong here? Let's go to this solution that I first wrote. Number of elements in the first row. Wait, what do you mean? Number of the elements will in first row will always be. Wait, what? Length of triangle minus 1. Number of elements in the first row. Length of triangle last element will be 1, 2, 3, 4. Visualize the deep. Oh, wait. So in this case also we had 1. Insert dependable dimensions m values. Yeah, right. dp for j in range n. Triangle minus 1 I. Bruh, I'm giving it to ChatGPT. Think. What is wrong here? Subtle issue. Updating the PS array in place from left to right, which can corrupt values if you still need for upcoming calculations. When computing previous of j, you are potentially overwriting a value that will be needed for. Oh, okay. So what do they suggest me? What do they suggest me? In order to do this, I need this and this. I need the previous values. Previous values should be same. So I will start from last. Do I have to start from last? Going back to my solution. This suggests that I start j from last. So if I want to start j from last, I'll start from I. I'll go to minus 1. I to 0. Now let's run this and see if it works. Pura wrong. Beautiful mistakes we make in inside my head. I'm naked. Now, my brain has stopped breathing now after 3 problems. So DP array has all zeros in it first, and then what I'm doing is, in order to calculate minimum sum of this, as it is 0 and 0, of course it will be as it is, that previous of 0 is 0. No, wait, just start I plus 1. Yo, this just, so anyways, first one is done, and then we come down. Let's see if z is equal to 0. Yes, z is 0. J is 0. If j is 0, then anyways, yeah, what they have said is, for each step, you may move to an adjacent number from top to bottom. For each step, you may move to an adjacent number of rows below. More formally, on if you are in index I of the current row, you may move to an index I or index I plus 1 on the next row. Okay, so from up I can come down or to the left. Come down or to the left. So the only thing that matters is the up and the value just before up. But now I'm updating my previous DP here. So what happens, bro? Yeah, so that is why I can't take previous minus 1. That is the reason I am not able to take anything from the previous array. So here using current might solve the problem. I think current will solve the problem, but the only problem is I still want to do it in just 1 DP, and how can I do it? So if I were to start my G, I'm anyway starting from I plus 1, right? So say if I'm on second column and on this index, so for this, the minimum sum that I can find should not be updated initially. Am I right? Or am I right? So so I need my previous part to be obviously done, but in order to have the previous part, so have I used another array here? If I've used a current, oh my god, I've done it just in 1 DP. Oh no, I've used next. Okay, so here we can't be stubborn. I think can't do it in off-n, we have to do it in O of 2n. So yeah, doing it in O of 2n I think is easy. I'll take current is equal to 0 cross n. But am I taking it every time for you? Oh, what is Pro done here? ChatGPT Pro is done just in off-n. Let me look at the solution here. So I'm starting from I and going back, iterating from right to left. Yes, sure. But if I'm iterating from right to left, what about have to compute some values, man. If it says that I can come from either previous row or I minus 1, no? Previous row or I plus 1. Yeah, I minus 1. How do I find the values of those things? Okay, so this is how I find the values of those things. First of all, let me see if this solution is actually working. No, it's okay. Point range and chain range. Find J0 and previous on 0 is time 0 0. Yes, this is the same. If J0 and if it's J0, that means my previous of J will just be the addition to the triangle value, that is thing above. And if J is equal to I, what happens at that point? If J is equal to I, and previous of J is equal to 2. Oh. Yeah, right. Else previous of J is equal to minimum. Yeah. I think I just missed one. Is this my solution? I was returning. What happened here? So here I wasn't supposed to come down to previous of n minus 1. Let's see if whatever I did should have written in minimum of previous. Let's solve. No, it won't. No, it didn't solve, right? So here there was one more condition. That is if J is equal to I. What does that mean? If J is equal to I, there is no previous. Then there is a minimum of 0, whatever is left, and that was given me. Very bad value. Could this have been solved without this solution? I think yes. The only thing that I needed to do here was float of infinity. Is it? Oh, float of infinity. Let's see what this is. Then the output came in as 15. Previous of J is equal to triangle of I plus previous of J. Previous of J will be this. Bro, why didn't this work? इसमें क्या प्रॉब्लम थी? Okay, let me come reverse. Will this work? Let's go. This worked here. So one more thing to note which I overlooked was the question. Didn't read it properly. We weren't supposed to go till here. We were supposed to come just to this row. So for that I did minimum previous. One more thing, we can't iterate straight if we are taking a single array. Just like in previous cases, we were either coming from up or from the left. So calculating the left plus first, then coming up. But in this we had to retain what was in the previous array at the position I minus 1. So for that we had to move from back. If I kept on reading from back. Wait a wait a wait a yeah, so another problem done. We're done with minimum passing triangular. Now we are left with two questions, that is minimum falling path sum, and then we have Ninja and his friends. After this we'll be done with the 2D path wala things. Taking a break, small break. Yeah. Shit, 260. Okay, drink some water. After this we have two problems. We have done 1, 2, 3, 4 problems till now. We have two more problems. We've done with 6 problems. I don't know about subsequences. We will do subsequences in some later video. For this we'll need 2 live streams. This is 1 day, this is 2 day. Then for this we'll need 1 day, 2 day. There are 4 days from now on. For this, let's say I take 2 days again, 6 days. Then we have Elias 7, 8, 9, 10, 11. So TP itself will take me 11 days if I do 2 hours to 3 hours per day. 3 into 11 is 33 hours. Bruh. So we need to study DP 33 hours more. Is it worth it? Yes, it will be. But going back to DP, how many problems did we have in total? Oh, 56 fucking problems we had DP. So we are about to do 56 problems, right? Last time when I did DP, I didn't do it perfectly. Go to minimum falling path sum. Right. Wink. Just show me the leech code, bro. Minimum falling path sum. Bruh. Tip. Bruh. Messed up. This looks like a long. Oh, it's C++. This looks like a long ass code, but yeah. Let's go to the question. Minimum falling path sum. Given an array and cross an array of integers. So after doing this DP here, I don't think I should ever forget DP. Given and cross an array of integers matrix, return the minimum sum of any falling path. Return the minimum sum of any falling path. through the matrix. Falling path starts at any element in the first row. Always start at any element in the first row and chooses the element in the next row that is directly below or diagonally left or right. Specifically, the next element from position row can be a white. Row plus 1 and column value. Okay. So for this, I need to start 3. Thinking in terms of recursions, I need to start 3 recursions starting. Wait a minute. I need to start n recursions, right? And then all my recursions go down and down and down and down. They keep on falling down. And they reach to a point somewhere in the last row. So it takes the sum, so whoever has the minimum sum, that will be the answer, right? Looking at this example right here, 157 and 148. So this have sums. Is that? Oh, the catch here is it can have negative values. So minus 19 minus 40 will give minus 59. That will minimize my sum. Alright, now thinking in terms of dp here. How do my dp solution comes into picture? Okay, the base case of my dp will always be if I'm in the 0th row. Can we do greedy? No, we can't be greedy here, because selecting a minimum value now will lead to missing out the biggest minimum value later somewhere. Okay, so I need to start from each one of them. So let's say the minimum, okay, so for each path, that's it. So I got the gist of dp. My dp will be dp. Okay, dp will be of cross length m. Let me do length of matrix is equal to very nice, and is equal to length of matrix, and it's n cross n, so we don't care. dp will be 0 cross n, or what if I dp is equal to matrix of 0. Yeah, perfecto. What is the constants on matrix? Matrix length is obviously greater than 1 and between 100. Okay, so dp of matrix, dp is equal to matrix of 0, and now we will start right from the second for n in range 1 to n for I in range, right? So yeah, in the end what do I have to return? Bro, this is in the end, I'll just write pass here. In the end I have to return minimum of dp, right? Now I will fill this out. Okay, when range 1 to n, so we are in the first, so we can either look in up, or we can look in previous minus 1, or we can look in previous plus 1. So for this, surely taking modifying the same dp gonna create a problem, right? Is it? Of course is it. It is. So in this case we can't use the same dp, we obviously have to use another dp, right? So for every I in range 1 to n, every time I'll create a new current, this is my current DP that I have to change. This will be of size, you know what, let me take this simply as a copy of matrix of I. Okay, I got matrix of I. So now I'll just, now I need to add, how many do I have? I need J also here. For J in the range, for J in range, and again and in this, first of all I'll have minimum of 3 elements that I need, minimum of 3 elements, right? That is up, left and right, and up, left, up, right. So up is equal to up, left. So there will always be up, but there can be up, left. Okay, there will always be up. So first, current of J is equal to dp of J. This is the previous. I'm gonna call dp as previous here because it will make more sense, right? And minimum of current here. Up. So after this, now if I is uplift is equal to something, right, is equal to something, uplift is equal to dp of J minus 1, upright is equal to dp of J plus 1, right? If J is greater than 0, else float of infinity. Similarly, value of this, if J is greater than n minus 1, else float of infinity. If J is less than n minus 1 times J is less than n, else float of infinity. Okay, and how do we update? For every point in J, my current of J in this plus equals to, oh my god, don't need this line, this is wrong. Current of J is equal to minimum of, first of all, previous of J, then I have left, comma, upright. Okay, this is our update. After the updation, after every J loop, my previous will now be whatever we have in current. Now what about current? Current will be the new matrix. Wait, current of J is already matrix, no? Plus equals to, right? Don't forget this. And then I'll return minimum of current. Wait, where did dp come from? What does dp mean? Following some prex previous. Right, bro, just run, man. List out of range. J plus 1. If J is less than n, j is less than n, j is n minus 1, j is less than n minus 1, bro. Wait, run. Current is not, yeah. Anyways, you are it. Yeah. Just one small thing that we couldn't think of. Yeah, this is quite good. So we did this using another current matrix. Let's go to C++ and see. What the hell is this? Yeah, we use the current here as well. This is okay. This is even better solution. Yes. Now we are going with 3DDP. We did many questions for 2DDP till now. Now let's do 3DDP. So these were the problems that I solved 1 year ago. So I was able to solve this. Chocolate pickup. You are given n rows and columns matrix grid representing a field of chocolates where grid of ij represents the number of chocolates that you can collect from. You are given n rows and n column matrix grid. Representing a field of chocolates where grid of ij represents number of chocolates that you can collect from the I, j cell. You have 2 robots that can collect chocolates for you. Robot 1 Robot 1 is located on the top left corner and robot 2 is located on the top right corner. Okay. Return the maximum number of chocolate collection using both robots by following the rules below. Both of them will collect the chocolates, okay? From cell ij, robots can move to cell I plus 1. Plus 1 is the next row. And previous column, next row, same column, next row, increase column. Yeah, same like falling path sum. When a robot passes through a cell, it picks up all the chocolates. The cell becomes empty cell. When both robots are in the same step, only one takes the chocolates. Both robots cannot move outside of the grid at any moment. Both robots should reach bottom row in the grid. Okay. So this is same as falling path sum, but this time this time what happens is I am falling from 2 different places at the same time, and when I come to the last part, so I update it, and in the last part whatever was minimum, that I was returning in the no. Wait, what was previous question? Minimum falling path sum. So here it is maximum falling path sum, but there is a catch. Whenever both the robots come in a similar like the same grid, at that time what happens is from their combined total, that grid is just counted one time. So if it could have been falling path sum like previous, then it's easy to just run falling path sum from 2 different locations and start solving it, right? But how do I get to know that both the robots have okay, so I was running J for I in range So for iron range, so for zero throw, anyways, we know what it is. Wait a minute. So first robot will be at 3, then it will take 2, then it is taking 5, and reaching 2, 12. Second robot is 1, 5, 5, 1, 12. Okay. Yeah, so is it better for both robots to take the maximum path just once? What if, let's say a robot is on a path. Yeah, there's one more thing here to consider. One thing to consider here is, let's say now both were next to each other and then they were about to go down. But if they go down greedily and just, let's say there's 4, 5, 4, so they'll try to jump on 5, both of them, but that will just result me plus 5, whereas if they could have gone on 4 and 4, then that could have resulted me plus 8. How do I so here the catch is I need to find out all the combinations. There are 3 cross 3, 9 combinations. No, there are 2 raised to 3. 2 raised to 3 combinations. 8 combinations. I need to find out all the 8 combinations and what is the maximum that I need to add it to the answer here. So let's go and start this coding question. Now that I have understood what to do I need just one DPRA? Bro, wait. Should I take 2 different DPRAs for both the robots? I think that's better, right? DP1, DP2. In rows and in columns, I need the length of columns. Reason for I in range in I will start from 1 plus. First of all, DP of 1 DP of 0th value it can't ever reach anyways. Yeah, 0. DP of 0 will be care about in I. So if previous of I is not float of infinity, if dp1 of I mean j, dp1 of j is not equal to float of infinity, not equal to 0. But what if, oh my god, oh, can't have negative values, then I am giving it this, that is its untest. It is not equal to -1. That means there was something. Then no, what do you mean? तो इधर हम लेंगे करंट, कर 1, करवटी, कर 2 is equal to 0 cross -1 plus 1. For G in range, n, अब हम क्या करेंगे? I can either come from up, that is up, previous or ahead. How did I deal with that? Up, previous or ahead? So up to will be there, something will be there. So up is equal to, so anyways I am taking max, so I will max later on. Up is equal to a very low value like -1 should work. तो सबको हम देंगे फिलहाल 0. या सबको -1 देंगे. up left, up right is equal to -1 initially, and then if current of dp1 of j is not equal to -1, and then up is equal to dp of j. अरे गधे, anyways up will be dp of j ना. Okay. उसके बाद if uplift कब करेगा? if j is greater than 0, then uplift is equal to dp of j minus 1. If j is less than n minus 1, then upright is equal to dp of j plus 1, and then here what comes here, current 1 is equal to maximum of up same thing happens for the same thing happens for but suppose इसका ऑपरेटर और उसका ऑपरेट मर्ज करे तो क्या करेगा? बोल बोल क्या करेगा? तो वो कैसे समझेगा भाई? Take me to the moon and let me follow the stars. Oh, current one off who? जे अपडेट कर रहा है ना? जी वो यूज़ करके अगर मेरे को मैक्सिमम आया इसमें वो यूज़ करके मैक्सिमम मेरे को फ़र्क पड़ रहा है. हाँ मेरे को फ़र्क पड़ रहा है. So how do I and here also I'll do the same, right? This is a tough question, man. What did I think before this? How was I supposed to solve that overlapping thing? Only way to solve that overlapping thing was I'm solving it for this and then so of course up will not be same. If what is same, bro? The only thing that can they can pass each other once and then their up can be same. What is happening here, bro? Shall I go to editorial or shall I just look at the video? Let's try it. I think I'll have to look at the videos driver, but so in DP, so this is a 3D problem, man, and my DP here is 1D DP. Trying to solve a 3D problem in 1D DP. What are the changing states? Changing state is the robot M and N. So what did he do? So I'm looking at the solution for j is equal to 1 to j. So j is equal to 0 to m what is m here, bro? Robot broken chocolate. If j1 is equal to j2, if my j1 is equal to So guys, I think I can't solve this question because I am thinking everything in terms of 2DDP right now. This question is in 3DDP. What went wrong, man? Time to look at the strongly brain. Fuck off. Let me see it. Given 2D graded RX stat from say robots can move to this. Robot passes through, picks up chocolate, cell becomes empty cell. When both robots stay in the same cell, takes only one chocolate. Yeah. Don't tell me. No. Awesome. ये क्या है भाई? कोड है कि क्या है भाई ये? Okay. There is chocolate become 2 also. Again, this is ChatGPT and telling him to explain why 3DDP not 2DDP make following path sum. Take this see. Let's break down why 3D and okay, falling path sum. It's typically falling path like triangle minimum path sum. Only one pointer of a person is moving from top to bottom. At each cell, you store the maximum minimum to reach that cell. That is a single agent scenario. Alright. But this robot chocolate problem, here's the twist that you have two robots moving simultaneously from top to the bottom of the grid. Each robot can move in 3 directions. Each step can be left, down, right, diagonal. Two robots may or may not be on same column. At any point you need to know current row you're processing, column of robot 1 and column of robot 2. Yeah. In previous instances, we just needed to know what row I'm on and what column I'm on, right? Here we need to know what row and column first robot and second robot is. That gives us 3 variables to track. Okay, this is how you figure out. But why couldn't we take current row and column 1, current row and column 2? Why 2D is not enough? If you use only DP of row and column, you will be ignoring one robot entirely. You cannot compress two independent agents into a single 2D state without losing critical information about their locations. It would override possible valid state, cause incorrect marking, fairly distant is better relative. So visualization of this is something like this. Row is equal to 1, you could have robot and do. Okay, that I understood, bro. Wait, so this isn't bottom of what? Bottom up. Let's see. in the end I'll return what will I return? I return m minus 1. Wait. dp of 0 0. Yeah. So this is what I return, right? So start from the below. I start from below. Think again, bro. What did I need to solve? I can move only from these points. I start from these points. Fuck. We'll find the solution. Find the solutions. Bottom up. So whatever is at bottom, that will be my base case. Base case will fill the last row. Okay. How do I fill the last row, man? Think of it as rows and columns. I got the rows and columns. So ADP is 0 for I in range rows, underscore for I in range rows, for for I in range rows, for I in range rows, for I in range rows. Okay. So order is in then it will come first row and column 2 forward. 3D recursion, 3D base case. Now why am I filling the last row? What did I use to fill in initially? I was doing bottom up. I was doing top down recursion. Every time I was doing top down recursion, was I? Wait a minute. रुक कौन नहीं दिया भाई? Starts from the top row. Where's the solution over down to bottom? No recursion memorization is used. Construct the answer from smaller subproblems. Bottom up. Yeah. Oh. That's why it's cut bottom up. Top down base case and recurses downward. Bottom up smallest input, top row and builds up. Top down DP is recursion plus memorization. Bottom up DP is iterative. This is also bottom up. Let's get to know what this is. Base case for column 1 in range columns, for column 2 in range columns. If column 1 is equal to column 2, then DP of rows minus 1, columns 2, DP of rows minus 1. So look at this solution, this statement right here. DP of row minus 1, column 1 and column 2. So anything from previous column 2 fill the last one now. Will be chocolate grid of row minus 1 column 1 plus row minus 2 and column 2. Oh fuck. So initially it will be addition of row minus 1 column 1 So this is last row fill up. DP of last row given two columns which are ranging from all the columns. What I'm doing is just taking last row. This is just taking whatever is above. Yeah, why so? Now I'm filling DP table from second last row outputs for row in range rows minus 2 to first. Okay, so we are finding the solution. So we are assuming that if I'm ending up on all of them in the start, what is the base case? Base case is about ending up on all the rows, combination of both robots ending up on all the rows. So it will be for i in range column 1, for i in range column 2, and then I'll fill out the values. dp of n minus 1 column 1 column 2 is equal to chocolate grid of n minus 1 column 1 plus column 2. Okay, so we started that robots have ended up on a certain position. Okay, and after that now we'll move upwards. Now while moving upwards, what do we consider? I fall down either from where do I fall down from? Either from straight above or from diagonally left up or diagonally right up. So for each, so for row in range, that's one. Then for column 1 in range column, for column 2 in range columns, what are we doing here? d1 in range this deviation of, so this is delta 1 in range this, and for delta 2 in range -101. Yeah, so like 8 combinations, right? New column is equal to column 1 plus d1, new column is equal to column 2 plus d2, right? If new column is in bounds, if both the new columns are in bounds, if column 1 is equal to column 2, value is equal to subtractive of row, comma, whatever the row is, comma, column 1. Else value of chocolate will be row of column 1 plus row of column 2, right? And then I add value plus equal to dp of row plus 1. Bro, what? If they are in bounds, then I'm calculating the value. I'm calculating the max choco is equal to max of max choco and value. It keeps on updating, and the max choco get placed based on all the combinations whatever we found maximum till now. In the end, we are putting it at every point in time. And then what am I doing? After all these things, after what things, man? After solving everything for a particular row, column 1, column 2, then I'm updating the value. dp of row and column 1 is max choke, and then returning the starting position. Very intelligent problem. 3D is hard to imagine, but yeah, getting to know that it is a 3D is a big thing. Why was it a 3D? So the changing parameters in usual falling path sum is the row is changing and the column is changing, right? So it's a 2D, but B were only dependent on previous rows. Oh, wait a minute, bro. Can this be converted into 2D then? Because this is also based on previous rows. So dp of 0, 0. Oh, I think this can be done in 2D dp. Nah, yeah, 2D dp, right? Change this question. ये भाई वो नहीं चाहिए यार. Three D DP using only 2D arrays, okay. One for current row and one for next row. Since at this point we only need values from the rows directly below, yeah, right? So space optimized dp, how is it? dp is equal to 0 for range column. Okay, so here row We don't care about rows, we just care about column now. So base case filling is to column wala loops. If column 1 is column 2, then next dp of column 1 column 2 is equal to chocolate gets of this next dp of column 2 is equal to chocolate gets of this gets of this. Filling the last row. After filling the last row, I go on filling every index of the new row, right? So for this, obviously I'll take current dp. Yeah, I've taken current dp. So for row in range rows, this is necessary because time complexity won't be reduced anyways. Then we take a current dp, and then for column in range columns, for column in range columns, and then for this, so we are getting unique value of column and this, okay, column 1 and column 2. First of all, finding combinations of all column 1 column 2. So for that I'll take the deltas, okay. After getting the deltas, I'll add these deltas to as a new column 1 new column 2, right? And then I'll check if they are within the bounds. Then I'll put value as 0 if column 1 is equal to column 2. I'm taking just once value, otherwise this. And after all this is done, adding the value to, oh wait a minute, next dp कौन है भाई? Next dp is where the answer of the last row is, right? So I'll add it to next dp, and max choice will be max choice, and then current dp will be max choco, and next dp is equal to current dp. Then what I'm writing, next dp is 0 and this. Yeah, we're done. This is the fusion solution. Space is O of c square instead of O of robots into c square. That's it. And this is O of r into c square into 9. Yeah. So I got this problem now. Good. So I won't try to write this now, because if I write this now, it is already in my brain. I'll try to solve this problem after 1 or 2 days, see if I remember anything. So that was about dp here. I think we're done with yeah, so we're done with 2D and 3D dp on grids. So now we have a long way to go in dp. So I think I might just start a new series of graphs, maybe. Or wait, I'll take a simpler topic right now. So thinking about right now, I need at least 10 days to finish the remaining dp problems, right? So if I need 10 days to finish dp problems, if I start a new topic corresponding to this dp, then I'll be able to do it before dp ends. So when dp ends, there will be another topic also which is ending. So I think last time I started bit manipulation. What happened to my son? My son got left on learning bit manipulation. Interview problems. Power set. Then we have advanced math. Tennis. Yeah, I think I need to go back to bit manipulation also. So what I'll do is, okay, that's it for today, guys. I'll start a new stream in 5 minutes playing Valorant. I think at least a game. Thank you for watching, whoever was watching, and I will play games now. Bye guys.